So this video is section 2.1 about imaginary numbers. We're going to start with just the concept of imaginary numbers that you should have done in the past. Okay, so basically anytime you take the square root of a negative, in the old days we would say that there was no real solution, but now we're going to say that it's an imaginary solution. So for example, if I said the square root of negative 4, because I know the square root of 4 is 2, and then that negative comes out as an I. So we would say 2i. On problems like number 1 here, the negative is going to come out as an I, but then in order to simplify the square root of 24, since it's not nice and neat, you might think of it as 4 times 6. And then you may remember, okay, now I can say the square root of 4 is a 2, so I'll bring that 2 to the outside. I still have the I out there. And the 6, even though you can think of the 6 as 2 times 3, nothing's going to come out from that. So we're just going to leave the square root of 6 on the inside. So that would simplify to be 2i square root of 6. Okay, on another example, number 2, so the negative is going to come out as an I, and then you can think of the 40 as 4 times 10. So because we know the square root of 4 is 2, I bring a 2 out. Keep the I that's out there. And again, even though that 10 is 2 times 5, there's nothing that you can bring out from that. So I'm just going to leave it square root of 10. And so that would be my simplified. Now, just to point out, on a problem like number 4, the negative can still come out as an I, and then you start to break down the 21, and you get 7 times 3, but nothing can come out. So it's okay if no numbers can come out. We would just leave this as I times the square root of 21. Okay, so the next thing that we want to talk about is on a problem like number 5, you could simplify the square root of negative 36 to be 6i, and you could simplify the square root of negative 16 to be 4i, and since those are being multiplied, you're going to have 24i squared. Okay, so how do we handle it when we have like an I squared or an I cubed or an I to the 4th? Well, our rule is you cannot have an I squared or an I cubed. You can't have any higher exponent than just an I. So it's okay for your answer to be 5i, but it's not okay for your answer to be 5i squared or 5i cubed or any higher exponent. So think of it this way. I to the 1st we know is just I. That's fine to have that in your answer. But I squared, now I'm going to show you the y, but after a while you're not going to care about the y, okay? If you think of I squared as being I times I, but remember the definition of I is the square root of negative 1. So I squared would be like the square root of negative 1 times the square root of negative 1. And you may remember from the old days, if you multiply a square root by itself, it just equals the number underneath. So anytime you see an I squared, you're just going to automatically change it to be negative 1. Okay, so what about I cubed? Well, if we think of I cubed as I squared times I, and we know that I squared is negative 1, so negative 1 times I would just be negative I. So for now, I'm going to get rid of this because I don't want you to think you have to know how to get that. Basically, you just have to know what we have over here in these blanks. Anytime you see an I squared, you're going to replace it with negative 1. Anytime you see an I cubed, you're going to replace it with negative I. Anytime you see an I to the 4th, again, you'll think of that as kind of like I squared times I squared. So negative 1 times negative 1 is positive 1. Now, I could show you the y. I could do the development, but let me just show you what it's going to turn out to be, all right? Excuse me. I to the 5th is going to turn out to be I to the 6th will be negative 1. I to the 7th will be negative I to the 8th will be 1. And if I wanted to, I could keep going on, but do you see the pattern? Basically, every 4 of them is a pattern that will then repeat itself. Notice 5 through 8 is the exact same pattern. If I wanted to, I could say I to the 9th would start over with that pattern up at I, and so like I to the 9th down through I to the 12th would be that exact same pattern, and it's just going to continue on. So that means down here on number 5, where I said 24i squared, well, I can replace the I squared with negative 1. So really this is equivalent to negative 24. Okay. Now on number 6, I to the 82nd. Well, we're just testing the pattern. So think of it this way. Hopefully you would agree, if I got all the way to I to the 80th, that would end one of the full patterns, right? Because it's a multiple of 4. So I to the 80th would be like right down here at the bottom of the pattern. So that means 81 and 82 would be that second number in the pattern. So that's just going to equal -1. Okay. When we go to the next page, so on a problem like number 7, if you have subtraction, you handle i's just like any other variable. If I'm going to subtract, I'm going to say 2 minus 5i. I'm going to distribute the negative, so plus 3 plus 8i. So combine your like terms, 5 plus 3i. And remember, it's okay to have an I in your answer. And I can't combine those because they're not like terms, so I would just leave it. Now, number 8 is going to be the exact same way, except it's addition, so I don't think you need to see that one. But look at number 9, okay? So if I were to perform just, regular algebra operations, I'll distribute that to I. So I'm going to have -4i plus 6i squared. So like we said, you can't leave an I squared in your answer. So I'm going to replace the I squared with -1. So I'm going to have -4i plus 6. In place of I squared, I have -1. So what I have here is -4i minus 6. And that's all I can do to that one. Okay. Look at number 10. So let's look at this first part. Well, the square root of -81 is 9i. Bring down my minus sign. The square root of -100 will be 10i. And it's okay to combine like terms, so that's just going to become -i. Okay, so we talked about how you have to change any higher power of I based on this pattern, okay? You can perform any kind of algebra operation on the letter I, add, subtract, multiply, whatever. So, but remember, by definition, I is the square root of -1. Now, I don't want you to rewrite this, but I just want to show you. So that means what's really going on here is you have 3 over 2 times the square root of -1. Again, I don't want you to rewrite it like that, but I just want to show you. And you may remember from your geometry days, we don't like to have square roots in the denominator, okay? So, and what you would do is you would rationalize them to get rid of a square root in the denominator. In fact, back in your geometry days, let me just kind of go up here and show you an example. Again, you don't have to write it down, just kind of look for a minute. In your geometry days, if you ended up with, like, let's say 2 over square root of 3, we would have said, oh, you have to get rid of that square root of 3, so multiply the top and the bottom by square root of 3, and on top you would have 2 square root of 3, and on the bottom you would have the square root of 3 times the square root of 3, which just comes out to be 3, which isn't any prettier, but we say that it's been rationalized because there's no longer a square root in the denominator. Okay, well, same thing is true for us now. We don't want to have a square root in the denominator. And since I is a square root, we don't want to have any i's in the denominator. So you would do the exact same thing you would have done before. If I want to get rid of that I from the denominator, I'm going to multiply both the top and the bottom by I. Now, if you want to, you can multiply by 2i, but then you'll have to simplify it. So you might as well, all you have to do is multiply by the square root. You don't have to multiply by the number in front of the square root. So on top, I'm going to have 3i. On the bottom, I'll have 2i squared. But remember, I squared turns into -1. So what you really have here is 3i. On the bottom, 2 times -1 is -2. Okay, so if you have an I in the denominator, you multiply the top and the bottom by I. But look at number 12 and 13. You have more than just an I. You have a subtraction on number 12, and you have an addition on number 13. Again, in geometry, let me come up here. In geometry, you might have had some in the denominator something like 3 plus the square root of 2. Maybe it was like 4 over 3 plus the square root of 2. And so in geometry, we would have said, hey, in order to get rid of that, you have to multiply the top and the bottom by the conjugate. So you would multiply the top and the bottom by 3 minus the square root of 2. Okay, that's your geometry days. So now you might have something like 5 over 3 plus I. Okay, so again, you're going to multiply by the conjugate. So you're going to multiply both the top and the bottom by 3 minus I. That's the conjugate. So let's look at number 12. So I look at the denominator. Right now it's 2 minus 3i, so the conjugate would be 2 plus 3i. And I have to multiply both the top and the bottom by that conjugate. Okay, so on top, I'm multiplying these two things, so I'm going to have to do FOIL. So on top, I'm going to have 10. The outer is 15i, and the inner is 8i, so that's going to be 23i in the middle. And then the last is going to be 12i squared. And I know I see an I squared. I'll take care of that in a minute. In the denominator, again, you have to do the FOIL, but notice, because they're the exact same parenthesis, but one's a plus and one's a minus, aren't the middle terms going to cancel out? And I'll show you in this case why the middle terms cancel out. But from now on, when you do this in the denominator, you're just going to have first and last. But think through the FOIL. The first would be 2 times 2 is 4. The outer would be 6i, and the inner will be negative 6. Those are going to cancel, and that's always going to happen in the denominators. Okay, and then I have the last, negative 3i times positive 3i is negative 9i squared. So when we clean this up, on the top I have 10 plus 23i, but instead of 12i squared, I'm going to say negative 12, since I know I squared is just negative 1. In the denominator, I've got 4, and then it's a minus, but that's a 9 being multiplied by negative 1. So if it's being multiplied by negative 1, isn't that going to turn into a plus 9? So what I actually have here is, let's see, 10 minus 12 is negative 2. Oh, let me make this a little bit smaller, sorry. So in the top, when I combine the 10 and negative 12, I have negative 2. I still have the plus 23i. And in the denominator, I have 13. So I'm not saying it's any prettier than the original, but there are no longer any i's in the denominator. And that's what we were doing when we rationalize. Okay, so let's try one more of those. So on number 13, again, you look at the denominator. Even though the 2 out in front is negative, it's the plus that I focus in on to determine my conjugate. So the conjugate is going to be negative 2 minus 3i. Negative 2 minus 3i. So when I multiply on top and I use my FOIL, I'm going to have, first is negative 2. The outer is negative 3. The inner is negative 8. So that's negative 11i. The last is going to be plus 12i squared. Okay. On the bottom, again, when we do the FOIL, I don't have to worry about the outer and inner. I'm just going to end up with first and last. So the first, negative 2 times negative 2 is 4. The last is going to be negative 9i squared. So again, I'm going to get rid of my I squareds. So let's see if you can handle this. Since I know that this is really just negative 12, if I combine that with my negative 2, I'm going to have negative 14 minus 11i. And in the denominator, remember that I squared is like a negative 1, so it's going to really become 4 plus 9, so 13. So that's my rationalized answer. So those are the notes for section 2.1.